Alright, so today we're looking at intensity level problems. So we're going to be converting intensities to intensity levels. Just a couple things at the top of the note sheet. If you remember loudness versus intensity, loudness is what we perceive and intensity is what the actual power per area is. So loudness is a perceived quantity where intensity is the actual quantity there. Intensity is the power per area, so we can solve for that if we know those two values. And then intensity levels measured in decibels. So just a reminder, the difference between intensity versus intensity level. A couple of other things. The threshold of hearing is 1 times 10 to the negative 12th. And then the equation that we're going to be using primarily today is intensity level is equal to 10 log of I over IO. And then if you look over to the side, you can see what those represent. So example 1, if we look at a cannon and it has an intensity level of 120 decibels from a meter, so if we're looking at a decibel meter and it's a certain distance away and it reads 120, what will the meter read if we have 3 identical cannons go off at the same time? Okay, now many of you would say, well, it's going to be 3 times the intensity level, right? So it would be how much? 360 decibels. Well, you wouldn't have eardrums then. You'd be deaf. The threshold of pain is right around 120 decibels. And 140 is permanent hearing loss. So then every soldier in the Civil War would be deaf if this were the case. Because there were, 10, 20 cannons being fired at the same time. And you just have screaming and ears bleeding on the battlefield, and then you'd lose when you fired all the cannons together. So no, that's not what happened. You cannot add intensity levels. Okay, they're not additive. Intensities are the only thing that are additive. So what are we going to have to do if we're given an intensity level to get another intensity level of 3? Well, we're going to have to get it to an intensity and then multiply the intensity by 3 and then back to a new intensity level. So we have to come out of intensity level to intensity, multiply our intensities, and then go back to an intensity level. Does that kind of make sense on the process, what we're going to be doing? So if we know the decibel level of 1, we want to know the intensity level of 3. That's kind of our unknown, and we can't just say it's 3 times that. First thing we need to do is solve for the intensity level of 1. So if I start with this equation and do some algebra here, I get to this equation right here. And I'm okay if you start with this one from now on. So if you want to write this equation down and start right here, that's acceptable. Again, just to kind of go through how I did that, I divide both sides by 10. I then take both sides to the 10x. So if you remember from yesterday's PowerPoint, if you take 10 to the x of a log, those cancel out. So now I then multiply by I sub 0, which is the threshold of hearing. So essentially I have the threshold of hearing times 10 to the intensity level divided by 10. And again, this is an exponent up here of this 10. So let's substitute. Your 120 for your intensity level goes right here. Divide by 10. And then here's your threshold of hearing. And many of you are pretty good at math, can do this in your head. What's 120 divided by 10? 12. 10 to the 12th times 1 times 10 to the negative 12th is going to be 1, right? Those are going to cancel. And again, how many significant digits does this intensity level have? 1. It's only the 1's digit to the right. So this only has 1 significant digit. That's why my answer here only has 1 significant digit. Okay? What would the intensity of 3 be? 3 times the intensity of 1, right? So that's going to be 3 watts per meter squared. And then I plug it in the equation back here at the beginning and solve for the intensity level of 3. So here's my equation. substitute it back in, and then solve. And if you notice, the intensity level goes up a little bit. It doesn't go up a lot. Sorry, I can't really scroll down for you to see that. Okay, so it goes up by 5 decibels. Questions on that one? Again, if you're looking at your calculator and doing this in your calculator, hopefully yesterday you got some practice on punching in the logs and 10 to the x values in your calculator. So I'd encourage you to do that. Questions on example 1? All right, let's look at example 2. Here we have 3 identical radios. We have an intensity level of 110 decibels. What's the intensity level of one radio measured from the same distance? Again, can we just divide by 3? No, you can't do that. So what we have to do is do the same process. Get it to an intensity. That's going to give us the intensity of 3 of them. Then we want to find the intensity of 1, and then take it back to the intensity level for 1. Well, how many decibels did tripling the number of cannons go up? It went up by 5. Now, if we're reducing the number of radios by 1/3, how much do you figure it's going to go down by? Roughly 5, right? Now it's going to be it might be like 4.6 or some number like that because it's a rounded 5. But our answer should be close to what number then? Should be around 105, right? Is what we kind of presume it would be based on number 1. So let's check that. Same process again. I'm not too concerned if you write all this stuff down in your notes. It's the same as the other stuff. Again, you can start with this equation, so you don't have to do all this algebra here. Again, I said you can start with this one right here. Substitute, solve it. So that's the intensity for 3. The intensity for 1, what are we going to do? All right, and then our last step is to take this intensity now and convert it back to an intensity level. So again, using this equation, substitute that new intensity in, and look there. This is what we predicted. It came out to be 105 decibels. In your calculator, take 10 times log 2 in your calculator. 10 times log 2. And what do you get? You get basically 3, right? So what is this saying? This is saying this, that if you double the intensity, okay? So instead of I1, you have 2 times I1, and then the I0s cancel. So if you double the intensity of something, what are you doing to the intensity level? It's going up by how much? 3. So every time you have an increase in 3 decimals, you've actually doubled the loudness, or double the intensity rather, of the sound. Okay, so just think of it that way. Every time you double the sound, it goes up by an intensity level of 3. Okay? So that's a good indicator to kind of make sure that your numbers make sense. So let's look at example 3. Here we have 4 car horns, and we're going to 9 car horns. So roughly, what are we doing to the number of the intensity? It's doubling it, right? So how much will our intensity level go up by? By 3 decibels. It's a little bit more than double. Okay, so it's going to go up a little bit more than 3, but that should be a good indicator for where my final answer should be. It should be roughly around 98, 99, 100 decibels at the most. Okay, so that's kind of what I want you to see by that, is that it's not going to go up by a whole lot in terms of the intensity level. Same thing, find the intensity of 4. Again, you can start with this equation right here. Plug it in. How are we going to find the intensity of 9? We're going to take the intensity of 4, divide by 4, and multiply by 9. So that's all we do on this one. Plug it back in. See how this is the same? I mean, it's the same thing. I9. So there's those two that we just talked about. Intensity of the first tiger, intensity of the second tiger. And then we add them to find the total. And we get this value for our total. And then we take it back using the intensity level. Now, I get a value of like 59.7 decibels in my calculator, but again, it only has one significant digit, and the significant digits for intensity levels are ones digit and beyond. So my 59.7 rounds to a 60 point to get me one digit on that intensity level. Does that kind of make sense, the process on these? So we're kind of adding a level of complexity to our problem solving. If you look at tomorrow's stuff, tomorrow not only are we going to be changing the number of items, but we're also going to be changing their distances. So they're not going to be at the same distance away. So if something is further away, or we move it further away, how does that affect the intensity level based on that difference in distance? So that'll be kind of tomorrow's work. But if you notice, tonight you only have 5 homework problems because again they're fairly intense, no pun intended. But then tomorrow you'll notice there's only 3 homework problems. So again, that's because there's, it takes a little bit more work for each of those. And then we have sound 3 notes. So we've got another thing on sound, and I really enjoy that. The chart there that shows the frequency that you perceive and kind of the loudness that you perceive based on certain frequencies. And then we have sounds and pipes and strings. So if you're planning on making an instrument, that's going to be really helpful in deciding how to do that. We then have kind of a review note sheet on there as well, and then some review problems and questions which will take us a couple days to go through. We then have a lab that will be meeting down in the lab between Mr. Mlott and Mr. Roberts' rooms, and then a review sheet to kind of get you